Have you ever just fallen down an internet rabbit hole? I stumbled onto a project called Meadow recently, and wow, it's one of the most ambitious, dense, and honestly, one of the wildest things I've seen in a long time. It's like a complete digital blueprint for a new kind of technology, and today, we're going to try and unpack it together. It all kicked off with this one sentence, buried deep in some technical document: a hypersonic edge alloy. I mean, the name alone sounds like it was ripped straight out of a sci-fi movie, right? It's the kind of thing that just hooks you and makes you ask, well, the obvious question. So that's our mission for this explainer. We're going to follow the breadcrumbs, starting with this really mysterious material, and just see where this rabbit hole really goes. What exactly is this alloy supposed to be? And who are the people, the architects, behind this whole vision? Okay, let's start with section 1, the hypersonic super alloy. Before we get into all the crazy AI stuff, we have to start with the most, tangible piece of the puzzle. This material they call T11ZC. So the documents claim this alloy has some pretty incredible properties. You can see them right here: low creep, low thermal transfer, and super high resistance to corrosion and heat. To put it simply, these are basically the holy grails of material science. This is the kind of stuff you'd need to build like next-generation rockets or hypersonic jets. And this isn't just an idea. They actually list the ingredients. We're talking about real elements here: boron, calcium, tungsten, nickel. This sort of grounds the whole concept in actual chemistry, but it also kind of deepens the mystery. How on earth do you combine these to get those properties? Well, the secret, according to them, is something they call the H4H catalyst system, and specifically a process they've named the boron pivot. Look, the science gets super dense, but the key takeaway is that they're proposing a totally proprietary, brand new method to create this superalloy. Okay, so we've got this seemingly impossible alloy, but who is claiming they invented it? And that question is what takes us from the material itself to the much bigger picture, the Meadow project. This is where we start to see the people behind the vision. The paper trail leads to two companies: Meadow LLC and Radical Deepscale LLC. These are the names listed as the architects and, well, the owners of this entire ecosystem of ideas. And you know what? A quick search brings up a very real, very public digital footprint. We're talking multiple websites, a YouTube channel, and maybe most importantly, public GitHub repositories. So this isn't just some lonely PDF floating in the ether, it's a whole ecosystem of connected projects. And this is really the point where the rabbit hole gets so much deeper. The alloy is just one piece of the puzzle. The GitHub repos start mentioning things like an aerial NPU, an Autumn AI. So you have to wonder, what's the grand vision here? What's the master plan that connects a hypersonic alloy to artificial intelligence? Which brings us to section 3, the lead edge philosophy. See, to understand their big plan for AI, we can't just look at code or hardware specs. We have to dive into their core text. This document that lays out the entire philosophical and technical foundation for the whole project. It's called the Lead Edge Ash Tree Reflex. And this document, it basically lays out a completely new way of thinking about computation, about language, and about logic itself. And this quote, it just nails their core idea. They argue that traditional code, often gets stuck in a loop when it hits an error. Their proposed system is reflexive. So instead of getting stuck, it's designed to always find a way forward, to always reflects to some kind of solution. It's a really fundamental break from how we typically think about programming. This whole reflexive logic is built on something they call the order of natural tools. And it's a strange but fascinating hierarchy. As you can see, it starts with these abstract problems, like a maze or a puzzle, and then it moves to very concrete tools, like a hammer or a knife. It kind of feels like a way of structuring logic that mimics how a mind might learn. Start with a problem and then figure out the right tool for the job. The document is packed with formulas, like this one, for what they call cognition encoding. Now, we don't need to be mathematicians to get the point here. The whole purpose of these equations is to define a new language for their system, a way to encode information based on that whole reflexive natural tools philosophy. So where does all this complex theory and philosophy actually lead? Well, the ultimate application, it seems, is a completely new architecture for artificial intelligence. So, meet Autumn. That's the name they've given to the AI model that's built on this entire lead-edge ash tree philosophy. All those concepts we just talked about, reflexes, mazes, puzzles, they are the very building blocks for how Autumn is designed to think. And the documents draw this really specific, kind of unusual line in the sand. They say with standard AI, you ask it to perform a task for you. But their vision of AI sentience is an AI you ask directly. The AI is then supposed to use its own personal journaling, think of that like a memory or an experience log, to generate a response. It's the difference between asking a calculator for an answer and asking a person for an answer based on what they've learned and experienced. And it makes sense, right? A totally new kind of software needs a totally new kind of hardware to run on. So they contrast traditional neural network chips, which they call looping networks, with their proposed aerial AI chip, which is explicitly designed for those generational reflexes. The hardware is actually built to mirror the philosophy. And that leads us to the final piece of this puzzle. Section 5, the aerial chip vision. All of this philosophy, all of this software design, it all leads to one final physical goal: creating a custom piece of silicon, a chip designed from the ground up to bring this new kind of AI to life. The aerial NPU, or neural processing unit. This is where it all comes together. The alloy, the philosophy, the AI. It's the physical hardware that is meant to make the lead-edge ash tree reflex a reality. And the ideas they have for this chip, which you can see listed here, are just as ambitious as everything else we've talked about. They're not just proposing a new layout, they're talking about re-engineering fundamental physics. The documents mention radical transistors, a circle transistor, and even, get this, aligning a neutron's mass inside silicon atoms. I mean, we are way past simple engineering here. This is bordering on theoretical physics. And this quote right here, this really summarizes the entire project's endgame. They want an AI that can generate data point blank, without the massive, energy-guzzling training models that power today's AI. Just think about that for a second. An AI that doesn't need to study the entire internet to answer a question. That, they say, is what true AI sentience really is. So, from a hypersonic alloy all the way to a new philosophy of computation and a blueprint for a sentient AI chip, the DART Meadow project is nothing if not ambitious. And it raises a pretty fascinating question, doesn't it? Are we looking at a practical roadmap to the future of AI, or are we looking at an incredibly detailed, sprawling work of digital philosophy? Either way, it's one heck of a vision to unpack.